Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we are going to discuss how to calculate tracer's time to breakthrough. In this case, tracer can be chemical tracer for, to identify or to analyze the connectivity between producer and injector, okay, chemical tracer. But actually, tracer can be anything. Even injection water from injector going towards producer can also be regarded as tracer. Okay, so it's basically a general formula that we will use to compute the time to breakthrough whenever we inject fluid. It can be tracer, can be water, injected from an injector towards a producer, right? And the formula is of course here. Okay, it's very straightforward, fortunately. So what is the time to breakthrough in days? It's 79 multiplied by this. So you need to know D, distance between injector and producers in feet, and then you square it, and then minus 4 times the square of RW. Of course, Wellbore radius in feet. Okay, it's very easy to know for the distance and Wellbore radius. And then here will be multiplied by porosity in fraction. You know that. Just ask your petrophysicist friend. And then viscosity, all right, in centipoise. You need to check the laboratory document, laboratory data, and then all multiplied by 1 minus residual oil saturation in water oil system. You check the core data, okay, core analysis data, and then multiplied by the logarithmic natural of D, distance between producer and injector, divided by 2 times RW. And everything here will be divided by the permeability. It must be average permeability between, between producer and injector, multiplied by delta P, which is the pressure difference between injector and producer. All right, so now I already have a completed computation, but I'm going to show you. All right, let's say I have distance between producer and injector 180 in meters. Most of the time, if you have map, it's in meters. At least that's for me. And then you see the distance is in feet. So in Excel, you can just convert 180 and then change it from meter to feet. So it turns out to be 591. Okay, of course you can change it, let's say 250, and then the breakthrough time will be changed. All right. And then let's say my wellbore radius is 0.354 in feet. And I check the core analysis report and the residual oil saturation is 0.21. And now let's deal with the delta P. First, we deal with the injector. Most of the time, the data that we have is the wellhead pressure for the injector. Let's say it's 900 psi. Okay, and I know the middle perforation, the depth towards my bottom hole, and it's 2,788 in feet. Okay, and then I also need to calculate the friction loss. When you inject the water, there will be friction loss in tubing and in casing until it finally reaches the perforation and injected into the formation. Okay, so of course you got the data for wellhead pressure, wellhead injection pressure. Of course, you know the middle perforation, the perforation depth, and you need to calculate, or maybe you can assume the friction losses. In this case, it's 100 psi. It's a product in another calculation in another spreadsheet. Hopefully later on I can show you how to calculate friction loss if you have injection water or if you have injection well. All right, so long story short, the injection pressure at the bottom hole, it's just, wellhead pressure multiplied by this, the pressure gradient of water 0.433, okay, multiplied by middle perforation. It's hydrostatic pressure. It's very easy, but you need to subtract it with friction losses. Okay, long story short, at the bottom hole, my bottom hole injection pressure is 2007. Or maybe I can just calculate, or I just can write it like that. Bottom hole pressure at injection, or injection bottom hole pressure. And of course, I also know the bottom hole pressure for my producer. I get that from pressure measurement. Maybe you have downhole gauge, all right? Maybe you have ESP, the pump, electrical submersible pump with pressure gauge. Or maybe you can also, lower down the pressure recorder and then you measure the bottom pressure. Let's say in my case, it's 300 PSI. I will also rename it to be BHP for producer. And I check my laboratory report, it's the viscosity 0.9 with porosity. I ask my petrophysicist friend or geologist friend, it's 0.17. Okay, of course you can change it, like change the viscosity or change the porosity. Change the porosity. Okay, you see the time to breakthrough will be changed. Okay, but this is my starting data. And now it's very important, the permeability. Let's say I know that the permeability is 100 millidarcies. Okay, and maybe I can put it somewhere else, and it's just like this. All right, so let's say I know the average permeability in reservoir zone between my producer and injector is 100 millidarcies. And now maybe I can start from 0. Just calculate it. 79 multiplied by D squared and then minus 4 times RW squared, close, and then multiplied by porosity, multiplied by viscosity, multiplied by 1 minus residual saturation, multiplied by logarithmic natural, ln of D in feet divided by 2 times RW. Okay, maybe it's like this. Okay, and then close again. All right, and then everything here divided by open parenthesis permeability 100 millidarcies multiplied by the delta P, bottom hole pressure of injector minus bottom hole pressure of producer. Close and close again. All right, so I have my breakthrough time in 131 days. Or if you divide it by 365, it's around 0.4 years. All right, so that's what happened. So if you inject water or if you inject tracer right now and you have a producer 591 feet away from your injector, then the breakthrough will occur at the day 131, day 131st. Or maybe you can also add one more here, but in months. For simplicity, you can just divide 131 with 30 days. So it's around 4 months. Okay, you inject now, and 4 months after this, the tracer or the water will arrive at the producer. All right, you might ask, why did I have permeability of TIF zone before I do this calculation? That's just another exercise. Let's say if between my injector and producer, I have tight or I have high permeability streak or I have thin zone with, let's say, very high permeability, 500 millidarcies, let's say, I can also do some exercises to estimate the breakthrough time. It's just, you have a freedom to test everything to make many scenarios, right? But for simplicity, let's go to basic. We have average permeability. Maybe you can just add it here, permeability average of the reservoir zone between your producer and injector. Okay, you can input that here, and then there you go. You have the calculation for the breakthrough time. And I think that's all. I hope you enjoy this video. I hope this video is useful. Thank you so much for watching, and see you again in the next reservoir engineering videos. Thank you.